Alright, this video series is going to teach us how to do two main things on our Doosan mill. This will be the same for most Fanuc controlled items. It kind of depends on how your machine builder builds it. It'll be a little different for each make. I know our robo drills aren't quite this handy, but the idea is the same, and with the PMC you can build it however you like. What we're going to do today are two main things. The first one is we're going to implement some shortcut keys for the hydraulic clamping. So those are signals that go to our hydraulic valves. And then the second thing is we're going to create some buttons here to close and open the door automatically, as well as an offset for the servo. So the doors will open and close automatically via a servo and a signal that tells the servo to go to door close position. Nothing too fancy. We'll just get into the details here. So the first thing we want to do is figure out what the addresses are for these buttons and these lights, because we want to know what they're doing at all times. So the way we're going to do that is by looking in the manual. So I'm going to pause this. So here we are at the manual. There's a variety of different pages in our Doosan manual that give you button layouts. So you have a button layout and a button layout, but you need to find the one that matches your own. So ours looks like this. So it matches this button layout. You can kind of see it with a little more description of what you're looking at, but the general shape of it is the same. And then the ones we care about are these two, which are blank. We care about those two. And we care about that one, and this one. So the reason we picked these ones is because it makes it a little bit easier to reprogram. So one of these is like an auto power off, and one of these is something else that I don't care about, and this has to do with something else that's not important. And what we're going to do is kind of trick the PMC into ignoring what they used to do and then giving them new functionality. And then these two, I believe, are blank. So these are going to be the clamp and unclamp, auto door reset, close and open door. In other machines we've also used this one, which was mapped to something else, but we took that map away and just dealt with it that way. So in a moment I will show you how to do that. So the way that you program this is you have to enable the PLC or PMC editing. You start with e-stop. Make sure you're still on edit. I'm not sure that matters, but that's what I do. Then you hit system, and I'm gonna go until it says something else. Then you find where it says PMC config. I'm gonna get real close to this so you can see it. Then you come to this screen and you have to arrow down and then right key over. And you turn this to edit enable. Yes. You come down here and you say programmer enable. Yes. And this kicks the PMC into an editable mode. Then you can hit system again, hit over few times, then you go into the ladder. And the first thing we're going to do is pick the address for one of these and see if it's being used. I'll show you how to do that. R4.4 is the actual switch, R24 is the light. We could be wrong, we'll find out in a moment. But I'm going to look for R4.4. Alright, so we need to get back to the ladder, so you hit system and over key until you see this PMC ladder. Then we need to search for R4.4, so hit there, and then I hit search menu. We're going to do this a handful of times. Say R4.4, search, and voila, it's right there. So if you hit this button, you're going to hit this button, you'll see that bit turn on and off. So normally you would never hit this button, so what we're going to do is just remove it completely. It's not even addressed, like it doesn't have a name, no one cares about it. So the way I'm going to do that is I'm going to say exit, so we're going to exit out of this search function. Then I'm going to say edit, and then that's a problem. So we have a problem. It's asking for a password to be able to write into the PMC, so we can't edit it. We need to get the password. There's two ways to do that. You can ask your distributor for the password, and if they're really awesome, they'll give it to you. Sometimes they won't, but most of the time I would guess that they will. Now, obviously, for obvious reasons, it may be protected for your own good. If you go in and screw the ladder up, then you could break your mill, or it could malfunction in some way that's dangerous, which neither of those things are good. But this video will help you show, or help you understand what can be changed, and hopefully give you a little piece of good judgment about how to do it. And then the second way to crack the password is to use Google. So I was able to get the password by, I Googled something like Fanuc PMC password help, and it brought me to a variety of forums. In those forums there were a variety of guys that offered their email addresses and said, hey, if you need a password, just send me the ladder and I'll send it to you. And that's what I did, and I got the password, and big shout out to those guys. They did that for me. I also asked my dealer, and he also gave it to me as well. So both ways worked, but either way should work for you guys. There's lots of good folks out there that help me out. Anyway, the password for this machine is 1976. You go in there, and then you have the ability to edit. So now we move on to our next step. Now we're going to search by hitting operator, search menu. We're going to say R4.4, and we're searching, and it found it here. So I'm gonna make this go away. So this is a power savings conditional button. So if I press this clamp button right here, you'll see that bit toggle. So in a normal day, that really doesn't do anything for anyone ever. So what we're gonna do is we're just gonna delete that from that bit of ladder. The way you do that is you're gonna exit, search, edit the ladder. It's asking for a password. The password for ours is 1976. Weirdly, this is the first mill that we've had that has a password. Now we go to zoom, so we're going to zoom into this particular rung. And we go to R4.4, and we're just going to add a straight line, which is effectively a delete. So you just hit whoop, and now R4.4 disappears. Now we're going to exit the zoom, and there you have it. So now there was another R4.4, I think it was down here somewhere. We're going to exit the edit, which will restart the ladder, because right now the ladder is paused or stopped. The PMC is running, well, excuse me, the ladder was probably running in the background, but we were editing a copy of it. So you say, hey, do you want to update the program? You say yes. It thinks for a bit. You want to write it in the flash? You say yes. On the Doosan mills, you don't have to go into there's another menu where you can write it back into the memory. This seems to do it by itself. All right, so we're going to do another search. So we're going to say search menu. We're going to search one more time for R4.4. Searching. Address is not found. That means we effectively deleted this button from the list. Okay, now we're going to start making the logic that creates this clamp toggle on, toggle off, and then if you hit unclamp, it toggles off clamp and toggles on unclamp. Does that make sense? Probably not yet, but we'll get there. All right, our next step is this. We have our Doosan electrical circuit diagram here, and thumbing through, they've got a whole inputs and outputs map here, just kind of pages and pages of the stuff. We know that there's a circuit board with a bunch of open inputs and outputs. It's called XT107. In the manual, they're calling it CB107 for some reason, but same difference. We have so what you can see here, X's are inputs, Y's are outputs. So input, input, output, output, and then these are the different bits of that particular output word or byte, or however that works. Then, so we can see here, fixture 1 clamp is here in output Y07.0. That'd be 0.1, 0.2, 3, so on and so forth. So we need to make this button tie into this output of fixture 1 clamp and fixture 1 unclamp. So what we do is the following. Come back to the mill and we have to search for that output. So we're looking for Y7.0. So I'm just going to hit search and I'm going to say Y7.0. And then I hit search. And voila, it's right there. Naturally, all outputs should only have one, so there's only one of them. So we have right here, we have this bit, and you can figure out what this bit is doing, but it has a bit of logic behind it. But this is just a bit that tells that output to come on. And this is triggered by the M code. So what we want to do is we want to add ladder around it that also triggers with the M code, and we're also going to incorporate a door close signal, so you can't have somebody accidentally clamp it while their hands in the tooling or anything like that. And then we'll also make it so that it toggles, and I'll get into that in just 1 second. All right, so now we're going to create a new net or a new rung. Fanuc calls them nets instead of rungs. Most people would probably know them as rungs. All right, so we got the contact, an output. I'm going to key over to this new point, and if I just put in the output, it adds all the lines in between. So what we want to start with is this button address here, which is R4.4, I believe. Come over here, and then we need to pick a register to use, or a variable. So this isn't that complicated. We're going to use a few tools to cheat about which one to use. Because I've done this a couple of times, I know which ones are open, but I'll show you how to find them. So we're just going to key in R3900 and 1. That's where we're going to start, and then I'm going to say auto. And it's going to choose R3901.0, which is the first available bit in that register. And then, because I'm really anal, I'm going to make this the exact same register as is what's in our other mills. And it's going to be R3901.1. So that updates it. And then I'm just going to exit this add, which inputs it here. Voila, we just created a new rung. How cool is that? Now, what I want to show you is you have the ability to look at an address map. So this shows you all of these addresses of these registers, and it shows you which ones are available. So we didn't use 0, we skipped to 1, and then nothing else in this whole neighborhood is used. And we're going to use a handful of them for our own items. Alright, to continue what we started, I'm going to cruise over here and I'm going to create another net. And this one is going to start again with contact. Oops. And then we're going to make a normally close contact, and then we're going to have an output. So the first contact is going to be our button again, R4.4. Just keying that in, hitting input. And then this one's going to be R3900.1. Oh, whoops. 3901.1. Then this one's going to be R3901.2. And there we go. So we've got R4.4, R3901.1, and R3901.2. I'm going to input that. It's going to say exit the add. So the next step is we're going to add another net or rung right here. And then we're just going to create a framework. And the framework's going to look like this, and you'll just understand why once it's all done. It's not entirely intuitive until you really give it some thought. So I just keyed around. Can't see where my fingers are going, but I just keyed around and using the arrow keys, I got to these different 4 points. And then I'm going to create a connection up here. And then over here I'm going to create another normally closed contact. And then I'm going to come over here and create an output. Alright, so now we got to give all these items names. So this first one's going to be R3901.2. This next one's going to be R3901.3. This one's going to be R3901.3 again. This is going to be R3901. These are flip-flopped and crisscrossed. And then looking forward, we need to involve the unclamp signal, which is going to be R3901.5. And then out here is going to be R3901.3. So what you'll see is this bit will latch on and latch off with a button press here. So let's have a look at that. I'm going to get out of this addition. Look over my work real quick to make sure I didn't screw this up. Exit. It says, hey, PMC still running. You want to update? You say yes. And then you want to write it in flash ROM. If you don't, when you restart the mill, it will lose all your work. Then I'm just going to pull out the e-stop. Turn it on. Ooh, actually that was unnecessary, but that's alright. And then when I hit this button here, let's see if I can show all of it. Toggles on, toggles off, toggles on, toggles off. And that's how that works. So now we have a toggling bit, which is what we wanted. We'll keep going. Alright, so now we're going to edit this rung right here. To do so, we need to change our settings back. So, because I did that test, I pulled the e-stop out, we're going to push the e-stop in, and that allows us to move these back. So, second one down is yes, bottom one is yes. Go back to the ladder. So we're right here. We want to edit the ladder. I'm going to zoom into this rung. I'm going to add our new contact. And for now, we'll tie it directly up to the output line here. And this is, here, let me hide this. This is the actual output, so this is a Y address, 7.0. So this is tied to a contact on the back of the mill. This is just an auxiliary setup. And then this right here is, we're going to say this is R3901.3, which is our toggling bit. Every time we hit the button, it toggles. And voila, there we go. So now the output will toggle with this. So now I've got the mill turned back on. Just just going to test it to make sure everything's working right. I'm going to turn this on, boom, like that. Then you can see right here, lights on, valves on, doing what it's supposed to. That's clamp. Now we want to make a light come on every time that solenoid is on. So that address is R24.4. Here we go. So to do that, we're going to add another rung right here. So I'm going to edit it. We'll create a net. It always creates a net right above where you're currently at as far as the cursor goes. Then we're going to create an output here, or sorry, a contact. Scroll over once. Output. This one's going to be R24.4. That's the address to the light. And then this one was Y7.0. Could be wrong. We're going to find out here in 1 second. But that's one clamp. Alright, so now every time that clamp signal is on, this light right here will turn on. How cool is that? I know you guys are excited. Exit the ad. Exit the edit. Hey, it says, do you want to update the program? You say yes. Right in the flash on. Yeah. So now, clamp is on, light is on. On. Boom. That's how it's done, son. Now we're going to set up the next button with that light. And you can just watch me do it. Alright, so now we're going to search for the next register that is the unclamp button. So search for R4.5, which is the address. Finds it here, and then we're going to exit the search command. We're going to zoom into this particular rung. Then we're going to do this cool thing that is insert a column. So it's going to insert a column here, and I'm going to make input that's normally closed after an input that's normally open of the same address, which basically makes it a always false input, or an AFI is what Alan Bradley calls it. And then you just say R4.5. Oops, 2 R's in there. Try that again. Boom. So that's always false. This is always false. We're not changing anything. Exit the zoom. And just for kicks and giggles, I'm going to make sure that there aren't any R4.5s hiding. There's the 2 we made. Oh look, there's another one that's push button savings, something we don't care about. So look, let's go in, zoom, we'll find that bit, R4.5, and then we're just going to straight line it across. Exit the zoom, exit the edit. Oh, no, hold on. Went too far. I didn't mean to exit the edit. Go back into editing, search menu, R4.5. We're going to make one last search. So that one we knew about. That's what we edited. That's all there is. Keeps looping. Alright, so now we've taken out all of the 4.5s. And I'm going to edit this, or exit the search. I'm going to go back in the ladder, where we used to be by going search R3901.3, which will take us back to where we were. Right here, I'm going to exit the search, create a net. I'm going to say R3901.4 here. Oh, no. That's wrong. Just kidding. R3901.4 here is the output. And then this is going to be R4.5 as the input. This name that's calling itself now, we'll change that in a minute. I have a video about how to do that. It's much better than what I could probably explain today on the spot, so I'll probably just post a little tag like right here. You guys can click on and learn more about. So now we add another net, a rung, and let's see, I forget how this is structured. It's one of these, oops. one of these, I think, and that. Alright, so this one is R4.5, R3901.4. This one's R3901.5. Now, we're going to create a new rung right here. And we're going to create this logic structure. It's kind of crisscrossy. Alright, now this is R3901.6, which goes here. This is R3901.5, it's number 5. And then this is Y7.1. Oh, excuse my company got here. Sheesh. Y3901.6. R3901.5. And this will be R3901.2. And there you have it. So now we have our 3901.6 is the toggling bit. Exit that add. So now we have this is our original switch. So that's our input from our switch. It goes through here, it'll toggle now. Let's test it. Alright, so now if I hit our unclamp button, it toggles. There you have it. So now we're going to edit this fixture 1 unclamp solenoid line. Edit this, zoom into this, and we're going to create a new bit here, and bring that up. This is R3901.6, which is our toggling unclamp bit, and there you have it. Exit that zoom, and then just prior to this, I'm going to create a new net. It is normally open to a contact out. This contact out is R24 point something. Hang tight. Let me look. 24.5. All right, so we're going to make this button be auto door open. That button is auto door close. This button will be auto door reset, and that light will tell us if the auto door is ready. So the address that we're looking for is R8.0. We'll start with the open switch, and we'll go from there. All right, so as before, we're going to search for R8.0. Go. So now they're all negated. Now we can use the button for what we like. Here's a quick note to talk about what bits we're going to use for the door open toggle and the door close toggle. So we're going to use R3900 3 through 5, and then R3900 6, 7, and 3901 0. And I'm doing this, it's not really important which registers you use. I used these before on another machine, and I want to kind of copy what I did before so that all the troubleshooting is the same across all the mills. So that's why I'm doing it this way. You could choose other values, you know, whatever. Okay, so now we're going to create the toggle switch. We're going to start by creating a net. And we're going to start with the first rung, which is normally open, normally closed, output. And then we're going to cruise down here and say another rung. Looks like that. And then we're going to create a structure for that last one, which is normally open, normally closed, normally open, normally closed. Little connection there, and then we got a normally closed, and then the output. Alright, so the switch goes here and here. So R8.0 goes there. Don't worry about the name, we can fix the name later. I'll do that in a minute. Because that name doesn't mean anything to us. And then the first of your bits goes here, so this will be R3900.3. The second of your bits goes here, R3900.4. That's already done. R3900.3, so bit number 1 goes there. And then these flip-flop, so first goes, this one is the second, and then that one is the third, and that's the third, and that's the second. So second, second, third, third. So R3900.4 goes there and there, R3900.4. And then we do the third, which is actually bit number 5, R3900.5, R3900.5. And then this one gets a little tricky. You look right here. We want to tie that to the door closed, meaning if you hit door closed while it is door opening, that shuts door open off. So we're going to choose bit number 7. So this is 3900.7, R3900.7, and then all of this goes to R3900.5. There's mud, first, second, third. Bit in the 3-bit sequence to make this latching system function. It's kind of a cockamamie way to do it, but it works. Okay, now I'm going to do the same thing for the door open command as I do the door close command. And that'll happen right about now. Now we've got 2 toggling bits. This one's for open door, that one's for closed door. So if I hit these little buttons, door open, door close. Oh, by the way, I have these laser engraved. There's a guy near us that has a laser engraver. It makes it look just like these. It looks really sharp, and it costs like $5 a piece or something. He doesn't charge very much for it. But if I toggle these, that's close, open, close, open, close, open, close. And then you can toggle close off all by itself. So now we've got to figure out where in the ladder we're supposed to add this stuff. I usually add new things next to what they do. So you put auto door stuff with auto door stuff, and fixture clamping stuff with fixture clamping stuff. So we can see here we've got a variety of auto doors. So we've got an auto door close, auto door open, solenoid relay. So these are Y6, 5, and 4. So we are starting with the open signal, which is Y6.4. So we're just going to search in the PMC to find Y6.4. Again, we've done this before, Y6.4. Search. Voila, here we are. Alright, so let's find a good spot. So I'm going to scroll around. There's a door open command. That's not quite it. We're looking for something with M52 in it. Oh, there it is. So M52's here. What we want to do is edit this particular rung. And we're going to say R3900.5 goes there, and then we'll tie this back up. So what this is going to do is either you can open the door with an M52, or you can open the door with an R39.5, and that signals this FRDOP, which isn't the actual output, it's just part of the process, which is nice because it prevents you from doing something stupid like try to open the door when it's still locked, or while you're in the middle of a cycle, which can't happen. But, anyway, it makes it smart. So now we've got to figure out what to do with this toggling close bit, that closed door bit. So we can come up here, just above this is M53, which is the signal that the mill will send in your G-code to close the door by itself. But we don't want to use that because this FRDCL is here. So when the mill is on, all this stuff lights up, so it'll connect across. But this goes through, lights this KFRDCL up, which is also here, which latches itself on. So the problem I have with that is that I want this auto door to close with your finger held on the button, and it closes while your finger's there, and then when it's all the way closed, then you can let go of your finger. And the reason for that is it keeps your finger captive and keeps you out of the door. It's another level of safety. So in order to do that, we go down to this next line, which is the rung that actually has the actual output. So you can see this is Y6.5. So that's the actual output on the back of the machine. What we're going to do is edit this particular rung, and I'll show you how that's done. We're going to start with just a general structure. This first one is going to be the button itself. So it will be this door close button, which is R8.1. This next one is going to be your door close toggle bit, which is R3901.0. This next one's going to be what's called DCL, which is it's an input to the mill that says the door is locked. So once the door is locked, it gives that input. So you just type in DCL. Then this last one is the toggle bit for the door close, which is R3905. And then down here, this one is the actual output to the open door signal, which is Y6.4. This next one is this same bit right here, which is R3905, and then this next one is DCL. So there's probably a little more elegant way to write that, but that works. This is all flip-flopped, and I think you can combine these. So what this does is it makes it so when we hit that button, it gives the output no matter what. So you're closing the door. If you let go of the button, the door opens back. Now, once the door is closed, this will all latch itself. Then, well, actually, this will latch itself too. So then, once that door is closed, this lights up. That's going to be false, which makes it pass through, and then that lights up. Same sort of thing here, except the difference is when you hit the door open button, this should toggle off, and if it doesn't, or it does, and that toggles off, which means that all of this is false and that's false, which means that your door is no longer trying to close itself. That's the point of all of this. I'm not absolutely sure that this is entirely necessary, but it works, so I don't really care to troubleshoot it any further. So then from here, we exit the Zoom, and then I wanted to talk with you about this keep relay. So you can see that this is a keep select auto door, is what we're calling it. And you can see the address is a K address, 10.3. So let's go find that. First, we have to exit the edit. It's going to say, hey, the PMC's running. Write that into Flash ROM. Then you can just use this side menu, shortcut to your keep relay, and just so happens to be that I was in that line, but there's a bunch of keep relays. They're used to turn on and off functionality throughout the machine, but this particular one is this guy. We're going to change it from a 0 to 1. You get two choices. It's either a 0 or 1. Most people watching this video is going to know that. Now we go back to our ladder, and this is on. How cool is that? So now we have full functionality of the button. The next thing we're going to do is tie in these little lights to the button outputs. So we're going to make it so that when the door is opening, it lights up this button, and when the door is actually closed, it lights up that button. Alright, so these little addresses here, R28.0 and R28.1, are the addresses to those two little lights above the buttons. Now we're going to map them here. We're going to start with editing, and then we're going to create a net. Go create it above the line above where you're at. We're going to start with 2. So start with the general structure. So that'll be the open light, and then this will be closed light. So what did I call it? R28.0 and R28.1. Oh, you can't see that. Come on now, who's driving here? So there you have it. That one had a name to it already, but that's R28.1. Then we're going to use the outputs. So this is Y6.4, which is the actual output. And then this one's Y6.5. And then this one is VCL. So what this says is that when we're actively trying to close the door, or sorry, open the door, that's on. When we're actively trying to close the door and the door's closed, that light's on, which tells the operator, hey, the door's closed, you can let go of the button. So the next thing we're going to do is make it so that this light right here tells us if the servo is ready or not. So if the servo's faulted, that light's out. Normally you want the light to be on all the time. Luckily, the servo has this little output we can use that we've tied into X10.6, and we're going to tie it out to R27.3. Here we are, R27.3. Type in right. And there you have it. So there's that portion of it. The next step is we're going to create another rung that will look like this and this, and the output will be to the enable feature of the servo. So the servo has an enable input that makes it so that it has to be on when the servo's running. Then, so what we're going to do is tie this side to the button, which is R7.3, and this other side will go to an output that we're about to find. I'll show you in a sec. Okay, so we're here at the I/O map. So we have access to everything in this, and then we have a bunch of stuff that we're not going to use, like fixture 4 unclamp and clamp, fixture 3 clamp, fixture 2. We're using fixture 1. We may use fixture 2 one day, but fixture 4 is really unlikely that we'll use. So we're going to remap this output, Y7.7. This is how we do that. So for now, I'm just going to put in Y7.7 here, and it gives you an alarm because we haven't cleaned it up yet, but it's used already in run 1334. It's kind of nice that it tells you that. So our next step is just to exit this ad, and then we're going to do a search for Y7.7. Alright, so there you have it. The next step is to tie in our little robot. We've got to tie in a handful of signals into the controls so that they can talk to each other. Okay, a couple other notes. On this line, so this is the line that sends the enable signal to the servo, or the auto door. And so this is this button, and I had it programmed backwards. I wanted it to go low when you press the button, so I had the polarity or the type of contact wrong. And then we added an e-stop signal. So the e-stop has to be out in order for it to be enabled. So if you hit the e-stop, it unenables or disables the servo. Okay, this next step is to make this robot give a cycle start command to the mill. The way we're going to do that is first we're going to search for the output of that button. So we're going to find the address of this, which is shown there. It's X37.3. Remember, X's are inputs. So the first thing we're going to do is search for X37.3, and we'll just keep searching. What we're looking for is a cycle start setup. Working robot. Oh, look, there it is. Boom. So this is called auxiliary cycle start. I'm not sure why the main cycle start button is tied into something called auxiliary, but this bit right here, st.a, is what we're looking for. So what I want to do is edit this rung. So we're going to edit, assume, then we're going to add a line. Then we're going to add contact, and then another contact. So let's see. One will be auto, which would be 012, 012. So if you haven't built it yet, I'll show you that in a minute, but it's going to be R3902. And then this one is going to be X10.5, which just is the input that we picked in the back of the mill that looked available. It's not being used, so we just used it. But this bit right here will be a toggle bit right here that will be auto. Auto has to be enabled in order for this to function. Then the robot is allowed to cycle start, and we did that so that hopefully we don't get someone debugging the robot and accidentally starting the mill and causing a crash at the mill. So that's how that works. Our next step is to create a signal to the robot. So this is an output from the mill to the robot that is called mill and cycle. Again, we're going to commandeer one of these outputs. This is Y7.6. So we're going to go find Y7.6 and delete all of this fixture 4 clamp stuff out of it. I won't show you that because you've already seen it, but it's the same process that we used for this one. And then we're going to do another output that's based off of, not another output, but we're going to tie that particular output into that R32.1, which is the lamp or the light on this cycle start, meaning the mill is in cycle. So that's our way of telling if the mill is in cycle. It's real simple. It's also worth noting that the way that Doosan made their ladder, and well, the way that Fanuc does it, is there's a really convenient M20 feature. So it's M20 is a robot call, and then the robot gives an MFIN, basically says, hey, you're loaded, and then it just continues. So you put your program in a loop and it has an M20 to the robot call and load. That's really convenient. It would be a much smarter way to do what we're doing, but unfortunately we have to do this same robot setup for a Haas and a Mazak. So we wanted to make the control system in the robot the same for every mill, and this is the way we're going to do this, even though on the Doosan or a Fanuc controller it's kind of hokey. Okay, I wanted to show you a couple more things. We're just doing some testing now. Doors are working, clamp is clamping. So let me show you how we got here. We had to change a couple more things. So the first one is this JMP function is a jump function, and then it ends with a JMPE way down below, like many rungs. But what this is doing is it's all of the fixture clamping logic, and you can turn that logic on or off. And you do that through this kfix variable, which is a keep relay. So it's keep relay 4.6, and you change it just like we changed that other keep relay. That turns this to false, which means we don't jump. And then I'll scroll through here. And then what we found was, if we have this keep relay on, this fixture 1 clamp keep, or this one on, fixture unclamp keep, what it would do is, it's a little hard to explain, but basically at the end of the cycle it would keep the solenoid clamped no matter what. And that's a bummer, because if you're wanting to troubleshoot something, you want to be able to unclamp the part on your own accord. So what I did was I added a series of logic, which is N176, which is the clamp, R4.4 and R4.5, you can see that here, R4.5, which is this button, that button, or M176 is the clamp signal. What I did is I made it so that it let go of this signal right here. So once it's on, it latches itself on. That's the problem, right? So it will unlatch itself if you hit any of these buttons, or if you start the cycle over again. So that worked out great. And then the other thing that I did was, let me search for R3901.5. Perfect. So this is our unclamp toggle, and this is our clamp toggle. I added 176 and 177 on both of these so that they're normally closed. So if they turn on, which we'll see in just a second, you'll see this flash, and then you'll see this flash. You didn't get to see that flash, I guess. And so what that does is, if you have this clamped already, like if you manually unclamped it to get your part out, it will release that button press and make it so you don't have two people trying to control an output. Because what you could have is, you could have it stuck on clamping, and then the mill says, hey, I need you to clamp, but then you're clamping and unclamping at the same time, and you don't actually grab your part, and then tools break and stuff flies. It's bad news. So, one more note. Now that I'm mostly done with editing the ladder, except for changing the names, I'm gonna make a backup of this ladder. So that way, if something goes wrong, I have this copy of it, and then once I change the names, when I get a little more time, I'll go in and make another backup of it and save that somewhere safe. Of course, I started with a backup. The very first thing before I did anything was create a backup, because if something goes south, you want what is on this machine, you want a copy of that. I've made the mistake of not doing that, and somehow ended up bricking the machine on a previous project, and it took me a minute to find a quality backup of what the mill used to be. And they're mill specific. You have 2 brand new mills on your floor, they may have different ladders because some of the parameters are set up differently. So it's not like you can just copy one from a different machine over. It'll have different parameters. Anyway, food for thought.